This is the Unit 5 test review. Today we'll review Unit 5 test. Our first question, question 1. We have a right triangle. The right angle is here. So we have a leg of 8. That's leg of 6. We know that the Pythagorean theorem is a squared plus b squared equals c squared. Pythagorean Theorem. We know that this is a leg and this is a leg and that c squared is the hypotenuse. And so we're looking at c here. They ask us a couple questions. Based on your knowledge of the right triangles and the Pythagorean theorem, which statement is correct? A, the empty square has a side length of 8 and an area of 64 square units. Well, we have to look for side length of 8, the empty square. Okay, so let's do the Pythagorean theorem to make sure we know. 6 squared plus 8 squared equals 6c squared. 36 plus 64 equals c squared. Run out of space. I move over here. 36 plus 64 is 100. Plus equals c squared. Apologies. 100 equals c squared. Take the square root. That's the inverse of squaring a number. C equals 10. So c is going to equal 10. And so 10 by 10 is 100 area. And so that is wrong. The empty square has a side length of 9.6. Well, we just proved that the empty square has a side of 10. So only one of the answers was C. The empty square has a side length of 14 and an area of, okay, so we know that's not true. So you have to actually do the Pythagorean theorem to find that missing side, the long side, the hypotenuse, opposite the right angle of 90 degrees. Question 2. The table below shows the side lengths for some triangles. Okay, so they have a side of 3, 4, and 6. Now, the smaller sides have to be the legs. The longest side's always C. So you have 5, 12, and 13. That's an A, a B, and a C. 25, 31, and 40, that's the smallest two have to be A, B, and the third one could be C. Determine whether the sides define a right triangle. So, in order for something to be a right triangle, we do the converse, which is just still the Pythagorean theorem. We are still just doing the Pythagorean theorem, and we're just asking ourselves if a squared and b squared, if they equal c squared, then if that's true, then yes, you have a right triangle. That's it. So here we do it. 3 squared plus 4 squared equals 6 squared. That's 9 plus 16 equals 36. That's not true. So no. 5 squared plus 12 squared equals 13 squared. 25 plus 144 equals 169. That is true. That both sides add up to 169, so yes. And 25 squared plus 31 squared equals 40 squared. Okay, I'm going to need a calculator. $21, 25 squared is 625. 31 squared is 961. So they add up to 1,586. 40 squared is 1,600. So they do not equal each other. So the answer is no. Question 3, right pyramid is shown below. The height of the pyramid is, here's the right angle here. So this has got to be A and B. And this, if this is the right angle, here's the leg. And then this is the hypotenuse. That is little c. The height of the pyramid is 12. The distance from the center to the base in the middle of AC here, segment, at x is 4 units. What's the length of the slant height? Not too hard. Let's see. A squared plus B squared equals C squared. 4 squared plus 12 squared equals C squared. 16 plus 144 equals C squared. That's going to be 160 equals C squared. So we're going to need a calculator to take the square root of 160, which is 12.6. If we're going to round our answer to the nearest tenth, we end up with C equals 12.649. Now look, that's the hundredths. I'm sorry. This is the tenths. This is the hundredths. And this is the thousands. So this is going to round C equals 12.6. The grid below shows different locations in Henry's town. Each unit represents 2 miles. So that's a key here. You had to count by 2. A lot of people miss this because they were counting. Oh, that's 2, 4, 6, 8, 10, 12. Wait, no, I'm sorry. 2, 4, 6, 8, 10. 10 units. And then it goes from 4 to 16, which is 12 units. So we're looking for the distance. What's the distance in miles between the post office and the store? Okay, so that's C, because this is the right angle. 10 squared plus 12 squared equals C squared. 100 plus 144 equals C squared. 244 equals C squared. So then you take the square root, 244, which is 15.6, rounded to the nearest tenth. And that's what it asks you to do right here. And then if you were to put the units in miles, would be the, but I think the program accepts just the number. Question 5. The figure below contains 2 right triangles. You can see them here. Which statement is true? Okay, well, we can do the Pythagorean theorem here once. This is B, and that's A and C in this right triangle here. Okay, if we do A squared plus B squared equals C squared, we get 5 squared plus B squared equals C squared. 25 plus B squared equals C squared. Oh, I can plug in for C squared, which I know. I'm going to put that in here. That's 13. So 13 squared is 169. I'm going to subtract 25 because they're on the wrong. I have to use inverse operations and go back to unit 1. B squared equals 144. The square root of B squared is the square root of 144. So B equals 12. Well, now I know all the way from A to C also, if they ask me that. They do ask me it down here at D, and you can see it's 15, so that one's wrong because from A to D is 12, and then from here to here is 3, so that's 15. But we do see that AD right here is 12. We just found that, so that's true. Now we have to find BC to see if this is true or not. So we do call that A, B, and C. And we'll go A squared plus B squared equals C squared. 3 squared plus 5 squared equals C squared. 9 plus 25 equals C squared. 34 equals C squared. Take the square root of 34. And C is going to equal 5.83. So you can see B is also true. Now if you do test corrections or you do the other thing, if you answered BC as 4, you need to explain your reasoning. You can't just say A and B and expect to get a half point back. You have to discover where you made your mistake and explain that. Question 6. Inslee used this figure in her proof of the Pythagorean theorem. A, we have A here, B, that's your right triangle, and C. In her proof, Inslee wrote the formula, the square root of A plus B equals C squared, which the following explains why her formula is incorrect. Now let's look at what she has here. What is she missing here and here? Don't we know that the Pythagorean theorem is A squared plus B squared equals C squared. And then when we put in at the end to find C, we need to take the square root of C squared and take the root of the entire thing, A squared plus B squared. And simplified, that could be C. But still, you don't know A and B, so this is the farthest that she could simplify. So let's look at A. The square of the root of the sum of A and B should be equal to the square root of C. Well, they're still leaving out that the sum of it should be A squared and B squared. That's why that one's there. The sum of the square of A and B, the sum of the square of A and the square of B should be equal to the square root of C. Well, no, it should be the square root of C squared. So that's why that one's wrong. The sum of the square root of A and the square root of B should be equal to the square of C. No, that's what she has up there basically, except she left the squares off. And you're left with D. The sum of the square of A and the square of B should be equal to the square of C. That's the basic Pythagorean theorem up here. Given a box with dimensions of 12 centimeters by 16 centimeters by 21 centimeters, how long would a string need to be to stretch from the top right corner opposite bottom left corner, as shown in the picture? Okay, well now, look at what we have here. We have a triangle here, and that's the right angle in the box. 21, and the back is 16. We're going to call this A and B and C. We're going to have to do the Pythagorean theorem twice in this problem. So we do A squared plus B squared equals C squared. And now we have 21 squared plus 16 squared equals C squared. Okay, 21 squared is 441. 16 squared is 256. Okay, let's add those together. We have 697 equals C squared. We're going to take the square root of both sides, and C is going to equal 26.4. Okay, now we have C, so I'm going to erase what I have for C here. I'm going to write 26.4, and then the height's 12. And now this diagonal here, it makes, this is the right angle over here, this height of the box. So we're going to use 26.4 and the 12. We're going to do A squared plus B squared equals C squared. A is going to be 26.4. B squared is 12 squared. So we just have to do it twice. There's a decimal point. 26.4 squared is 600, basically 697 if you round it. 12 squared is 144. And that adds up to 840. And if I take the square root of 840, I end up with 29. It rounds to 29. That was the answer for question 7. Question 8. 3 boats on the ocean are located near a buoy, as represented by the diagram below. The distance between the 2 boats, boats 2 and 3, there's 2 and 3, is known to be 65 miles. Well, we know then this whole distance is 65. And from here to here is only 25. So if I subtract that, 65 minus 25, I left with 40 here. I know that if I do the Pythagorean Theorem here, 30, 40, if I can find the distance between boat 3 and 1. That's a right triangle. I'm going to end up, between boat 1 and 3, I'm going to end up with 50 miles. Let's see if they ask that. The distance between the buoy and boat 1, the buoy and boat 1 is not needed to find the distance between boats 1 and 2. That's not, we don't know that distance. We'll call it C sub 1, and we'll call this C sub 2. Okay, we don't, yeah, no, we need to know those distances. The distance between boats 2 and 3 is not needed to find the distance between the buoy and boat 3. The distance between boat, yeah, no, we needed to know the distance, and that was given. We needed to know the distance between boat 2 and 3, then we subtracted the distance between buoy and boat 2. So that's not right. The distance between boats 1 and 2 is about 16.5 miles. Well, we're going to have to do the Pythagorean Theorem here. And it says 16.5 miles. Well, now look. You can already tell this is 25 and this is 30. And this is a longer side than both of those. So that definitely is false. So you don't even have to do the math. The distance between boats 1 and 3 is 50. Well, let's figure it out. 30 squared plus 40 squared equals C squared. That's 90 plus 1600 equals C squared. 2500 equals C squared. Take the square root. And C equals 50. So that's why that is true. Now, when you do your test corrections, you need to show this work right here. If you're doing test corrections. Or if you're doing test retake stuff. The paper for test retakes. The distance between boats 3 and the buoy, boat 3 and the buoy is 40. Well, we found that. So that's true also. So D and E were the right answers. Now don't just put D and E, you need to give you have to explain how you got your answer. You have to do your 65 minus 25 equals 40 miles. And the final question. Question 9. 3 sides of a triangle measure 8, 10, and 12 units. Is this a right triangle? Prove it using the converse. Okay, well, the converse says A squared plus B squared equals C squared, only if they're equal. Now you put the 8 in there. Still put the question mark, and that's 12 squared. Moving over here, that's 64 plus 100 equals 144. And you end up with 164 does not equal 144. So therefore, that 3 dots means therefore, this is not a right triangle by the converse of the Pythagorean Theorem. This was worth 2 points. You got 1 point for this this here, and 1 point for the explanation. So that's a good one to target test corrections and retakes. This is the self-reflection and test corrections. This is for retakes. Our full credit. given after school. And if you didn't finish or you missed, you were absent for the first test, you must take the retake. Make sure you get your parent's signature to get a retake. Unless you're were absent and didn't take the first test, it's mandatory. And these are error notebooks. These are test corrections. This is the format for them. You do your mistakes here. From Illuminate. And then your corrections are here. Work the problem correctly and then explain your mistake. 2 parts. That's why just putting B and D or B and C, that's not going to get you the credit. Well, good luck, okay, and get those points in. You have about a week before the quarter terminates for work to be turned in.